Hello everybody, welcome back to the shop. For today's project, I got something that's a pretty simple repair, but it comes with a pretty neat story. Most of you know I'm a fireman, and the thing about firemen is we're kind of a big family that, well, we fight a lot, but we work hard together and we get a lot of things done together and we train together. And over the years, their family is kind of like your family, and you know, right? Some years ago, we lost one of our firemen in Orlando, and he passed away, and it took a lot of firemen by surprise, and a lot of people struggled for a long time. And his brother works for us still to this day. In the fire department, there's certain things you pass along. For instance, your helmet, sometimes your badge, some guys it's a belt buckle. In this case, this happens to be a tool, and it was passed down from his brother, and he uses it at work still to this day. And during training, it broke. And this tool is called a pike pole. This particular tool has a steel shaft, and it should have a steel head affixed to it like such. It's used for opening up void spaces primarily, meaning we want to use it to pull through drywall ceilings. We want to pull the drywall down so we can get that water up into the attic if the attic's on fire, or into the void space between the first and second floor where that fire might be running. We want to use it to open up tongue and groove. God forbid you ever have to do that, because those firemen out there will know about what that's all about. Looking at this particular one, it has, well, somebody's done a repair somewhere along the line on it, and it's a little bit less than satisfactory, and we'll just leave it at that. When I look at the broken welds, there's not a lot of penetration. There's a lot of weld bead laid on there, but the weld bead hasn't penetrated into the tool itself deeply. The setup isn't the best, and I believe, looking at this, that somebody shortened this tool somewhere along the line. This head should have a stop that sticks out about that far that fits down inside the pipe. What I would like to do here would be to turn this down, put it in a 4-jaw chuck, turn it down on the lathe to diameter, get it to fit inside the pipe, plug weld it on each side, and then do a circumferential weld on the outside, but that's not gonna happen. This tool, somebody has taken that option off the table. So the next option we're going to do here to make this repair on this tool and get this family heirloom back in the fire service where it belongs is we're going to take this to the grinder. We're going to try to grind this square. We're going to get all this weld boog off there. Okay, what we've got here is we've got the head of the pike pole and the vise, and you can see there's not much to work with here. Now normally when I do grinding, I'm a fan of a flap disc, but we're not going to use a flap disc. What I've got here is a diamond cutoff wheel, and I'll tell you why I'm going to use this and a hard cutoff wheel. And the reason I'm using these is I want to try to put a fairly defined edge in here, and a flap disc just won't get in there and cut like I want. So I'm going to work back and forth between these two tools and try to give me a little stop here to kind of locate this thing and get all this very porosity type weld. There's a lot of porosity in this weld here. I want to get all that out of there, get back to good iron, and we'll try to make a nice bevel so we can get in there and add a lot of filler and get that way down into that root, get some heat in there and get it really welded in good. Good. All right, so I got you over here at the bench. We're all set up here. We've got some 309 cut down. We're gonna weld TIG. I got it set at 100 amps DC. We're gonna have a pointed tungsten. We're gonna come in here and do just a couple of little tack welds. I wanna check the straightness of the head. Once I get it tacked in place with a couple of tacks, I can make a few adjustments there and get that thing lined up if it's not correct. Since we're welding in DC TIG, I'm just gonna wear sleeves. A lot more comfortable than wearing a welding jacket in the summertime. All right, so to start it off, one little tack weld here on this side. We'll take the tool, check the head for straightness, One of the things we're gonna do on a thick piece of metal like this, I'm not gonna come in and rush it and just hammer the pedal. I'm gonna try to kind of put a little preheat in it, preheat the area, let the part start to come up to temperature before I start applying a lot of filler metal in there. I don't want to heat shock it because that doesn't aid to a good weld. One other point I want to make is that I'm grounded straight to the tool, not to the workbench when I'm doing my welding here. There's a natural bend in this pole, not a natural bend. I'm sure it was put in there by some training evolution somewhere along the line or some firefighting effort. But that head is right about where we want it. So we'll flip it over and we'll put a tack weld on the opposite side of where we had the other. And the reason we want to do that is when we put the metal in there, it's a hot liquid, it's expanded. And as it cools, it's going to contract. So the weld that's on this side is going to start to naturally pull that head away as it cools to make that head sideways. So if we put a weld on the opposite side, do the same thing, those two will fight against each other or pull against each other and tend to keep that head at a much straighter angle. Same thing as before, we're gonna roll into it nice and easy. We're gonna put some heat into this big thick weldment here. Not gonna go in and go pedal crazy. Just gonna put a little bit of a tack weld in there, get it nice and warm. Give everything time to get hot so we don't rush it. We'll check the head again. The tool is nice and straight. So we'll do one more front to back. Something really interesting. You guys saw me grind this, right? You know I took all the paint off it all around the area. It's ground to bare metal. But as this thing starts to come up to temperature, I smell burning wood. It smells a little bit like a campfire and a little bit like creosote. So as we heat the head of this pike pole and the shaft of it's off-gassing, it's letting off those same things that we try not to breathe in when we fight fire. This right here will be the fourth weld. So we've on these sides, we're here and here. So while we're set up here, we're just gonna go ahead and weld it. Again, I'm just rolling in here nice and slow, letting the heat build gradually, not forcing this to take a heat shock, because I want the penetration to be nice and deep, way down into the head of this tool. So let's just get this situated here on a good ground. We'll come in and weld about another quarter of this. She's starting to heat up pretty good right now. Where I'm resting on the shaft of the tool is getting pretty warm even through the glove. That's welded on there beautifully. What I want to do that I don't normally do on TIG welds, but because of the shock loads and the stress that this tool could potentially take, and the fact that somebody's life could rely on that weld right there, I'm gonna go ahead and put one more pass of weld around there. I'm gonna add some extra reinforcement in the filler material. Not a common practice of me, because usually when a TIG weld goes in, I know it's rooted in because I can watch that weld as it goes in. I know it's laid in all the way to the bottom. However, I just wanna put that little bit of extra coverage in there, make sure this thing is over-engineered for what we're gonna do. We're letting the post-flow argon continue to cover this weld. Now, I'll explain why. We're using 309 filler, which is a stainless alloy. Stainless alloys are very susceptible to alteration from the oxygen out of the atmosphere. That's why a lot of times you'll see stainless discolor, get the rainbow colors in it at relatively low temperatures when you heat it. So to allow that metal to cool a little bit longer and be protected from the oxygen in the atmosphere, It's more of a aesthetic thing at this point in this tool, but if this is left stainless, this will be a fairly nice looking weld. That weld right there will not break. You could bet your life on it. You know, guys, the firemen in Orlando, when we lost Maddie, it was very sudden and it was very unexpected, and it shocked a lot of us. He was an icon on the fire department, did a tremendous amount of training towards not only the Orlando Fire Department, but trained people basically from all over the world. He was a very well-respected person. And so in saying that, I want to pass forward a little bit of pride in being able to, put this tool back in service for his brother. I was originally going to take this and strip it all down and paint it all up and make it look amazing. And I sat here actually while I was welding it, while y'all were watching me weld it, thinking in my head, I don't know if I want to do that. I don't know that it's my right to do that. You could smell wood, burning wood, that kind of that creosote-y type smell when I lit up on this. His brother put that all in here. Now, there's a certain amount of damage I had to do to make my weld, but I don't think I have a right to take this off. If he wants to take it off, that's on him. So with that, I'm gonna call this another project done. I appreciate you guys coming along, hearing the story. Thanks everybody for watching. Be sure to subscribe to the channel, like down below, give me a thumbs up. And if you've ever done these kind of repairs in your shops, tell me about your story. I'm interested in hearing about it, as well as everybody else that tunes in the channel. Thanks for tuning in. Thanks for watching the channel. We'll see you real soon.